So I've been asked to go through question 6 here. So at a sideshow carnival, a player is allowed 6 chances to score a goal by throwing a ball into a small net. The sideshow operator estimates the probability of scoring a goal at any time is 0.6. Let X be the discrete random variable representing the number of goals scored in 6 attempts. So we are looking at state the distribution here. So this one here, we are looking at X is distributed as a binomial. We should know that with 6 trials and 0.6 chance of success. So this is N, this is P. Okay, next one here, evaluate this to 3 decimal places. So this is 6 combination 1, 0.6 to the power of 1, 0.4 to the power of 5. And this, I wouldn't have typed this in because it's only worth 1 mark. I would have just put this in my calculator and I would have got 0.037. Okay, the next bit, explain what you have evaluated in P. So if you've got used to binomial distributions, you should know that we're looking at, our formula here is N. Now, this isn't obviously you don't need this to answer the question, but it helps. So our formula here is probability K, 1 minus probability. So this probability here, N minus K. This one here gives us the fail amount. This here is the amount of success. So this is the probability that X equals K. And so here, because we've got the success is to the power of 1, and we've got 1 here, this is saying 1 goal scored exactly. Or we would say we've calculated the probability that X equals 1. Okay, this next thing should be done with the calculator. I'm not going to spend too much time here, but you're pretty much going to use, this is what we've got here, probability equals X equals 0, probability X equals 1, probability 2 less than equal to X less than equal to 5, and then probability X equals 6. So these are easy to solve, so we get 0.004, 0.037, this is 3 decimal places as well, I should have specified, 0.912, and then 0.047. Okay, players pay $10 to make 6 attempts at scoring goals. Scoring 6 goals wins you $50. Scoring between 2 and 5 goals wins you 10, and scoring 1 goal wins you 5. Scoring no goals does not win any amount. So you're looking at why. So why is the payout from the results of X? And so in this, the expected payout in total is going to be e to the y. It's going to be, well, if we score 0, it has a 0.004 chance of happening. So that's from here. Plus our next one was scoring 1 goal, gives us $5. So we're going to have $5 here, and that was 0.037, and then plus it was $10 for the next one, which is between 2 and 5 goals, which is this next one here. So 10 times 0.912, and then we've got plus. Our last one here is you can get $50 if you score all 6. So we've got 50 times 0.047. So that's find the expected amount, so we need that, and then this, when you put it in your calculator, is going to be approximately $11.65. So the next question, it's only worth a mark. Explain why the situation does not favour the slideshow operator. It's because the expected winning is higher than the cost to play, so you would expect here, it's not guaranteed, but in the long run, you expect to win $11.65 the more you play it. So win $11.65. Now, I'm writing this really quick hand. Look at the actual solutions I've got up that I've sent to you. And stake equals negative $10. So then win $1.65 in per game in long run. In long run. Okay. Cool, so the next bit here, the sideshow operator decides to increase the level of difficulty in order to be favoured by this game in the long run. This requires reducing the probability of scoring a goal at any time to no more than P. Reducing the probability of scoring a goal at any time to no more than P. So this is for the next bit here. Explain why P can be calculated from the following mathematical statement. So this is actually good for us if we know how to unpack this. So yes, it looks complicated at the moment, but looking at what we know from combinations, which is C, K, N, the probability of N, and then the fail probability, which is 1 minus P to the N minus K. Now, oh, sorry, that's not N up there, that's K. Now, this one here, probability of success is to the power of 1, the probability of a fail is to the power of 6. So this here represents probability x equals 1. Now, the 6 out the front is because the combination of 6 choose 1 equals 6. So that's where that comes from. So that gives us that value there. This 50 P6, the P6, so the P6 here is given by the probability of x equals 6. That's the chance of it happening. Now, I'm going to highlight the 5 and the 50 because the 5, 50 and 10 we should have realised from the part before is the money that was in the question. Now, we look at this here. Now, forget the negative at the moment, the 1 minus. We've got here, this probability here is the probability that we fail 6 times. This is the fail probability, and it's to the power of 6. So if we fail 6 times, we're looking at the x equals 0. This probability here is the probability x equals 6, which we've had before, and this probability here is the probability x equals 1. Okay? Now, in this space, these particular numbers, if we do 1 minus, and I'm just going to put a bracket around these because you'll notice that these all have a common factor of 1. So if I put a plus, and I leave that negative and I put the negative bracket around here, this is saying 1 minus these values. Now, from our knowledge of probabilities, 1 is if we have a 100% chance and then we take away the probability of these things happening, that is the same as the statement. This statement here is the same as the probability that x equals 2 plus the probability of x equals 3 plus the probability x equals 4 plus the probability of x equals 5. Now, when we look at this statement here, we've got the probability that x equals 1, the probability that x equals 6, 2, 3, 4, 5. We've got every value here. Now, the 0, the probability x equals 0 isn't here because you make no money. So this statement here is the expected value of, so this here, taking that out, this is the expected value of y. So explain why P can be calculated from the following mathematical statement. This is the expected value of y. If we look at the bit before up here, so you're looking at e to the y equals this statement. Now, I'm just going to stop there because if I get too caught up in this, it's going to take bloody ages to explain. So that is saying that we've changed these P's that we would have picked before. This is just this statement that we've done previously, but we've got probability and the opposite in there. This is our binomial distribution. So this is the expected payout, okay? And then it's got less than 10. So the reason we've got this less than 10 is it's saying the expected, maybe we'll use e to the y, is expected payout from game. And we've got here less than 10. Why would they pick less than 10? Well, that is the stake up here. So they've said you can pay $10 to play. Players pay $10 to make 6 attempts at scoring a goal. So we've got here, we need it to be less than 10 because that's how we do it. So that's what this statement here is. And in my solutions, let me have a look. It's a bit of a confusing one, but the numbers are sat on it for sort of explaining where the different bits can be found. Okay, so we've got, it's all there in that bit. You can see the, therefore we've got e to the y on the bottom there, and the individual bits of that explain why p can be calculated from the following mathematical statement. It's actually the expected one we're just putting a p-value in there. I can go through that more in the morning, but the point of it is all we're looking at here is this value here. This side of it is the expected, this is e to the y, and that's all we've calculated there. Find the exact value of p, just put it in your graphics calculator, graph this. Okay, you end up with a graph, when I looked, not drawn very well, but it goes like something like this, and then you graph y equals 10, and this will give you probability equals 0.5, which means in this particular one, we need to go, look, the probability has to be between 0 and 0.5. Now, you can't have it equal to 0 and you can't have it equal to 0.5, because if it's equal to 0.5, the expected value is 10. You're not making money. All right, I'm going to stop there. I've rushed through that. I hope that makes sense.